Okay, so apartment complexes can be, and other types of multiple dwelling units can be a really great way you can hook them up. Can be a great way to get a lot of customers hooked up for cheaper than individual homes. You can get the price down for what it costs you to actually hook these people up compared to a single family home. So they can be a really great way for a wireless network, whether it's Althea or otherwise, to get started and quickly kind of get it to a hold in the community. But there are some things that make this difficult. Oh, I thought you said something. So we've talked a little bit about intermediaries and how we would get service to this type of building. The situation is, we've got a community like this in our neighborhood. We want to provide service into the residents. We might do a very similar setup to this. Set up some wireless equipment up on the rooftop and bring service to the building using using our wireless ubiquity equipment, and this could even potentially be an intermediary. A building like this in a community, these apartment complexes are often tall buildings, often have good access to power, and can make great intermediary sites for connecting the residential homes in the neighborhood. But you also want to be able to connect the tenants inside the building. That can be trickier than it sounds. You would think if you are set up on the rooftop that it would be easy to get from there into the tenants, and it can be, but it can also be kind of difficult. The first thing that a lot of people ask me when talking about MDUs is, you've got all this wireless gear on the top. Can we, as tenants inside the building, just connect directly to that wireless equipment? And if not, why not? Seems like you're already there. Why can't we just connect our laptops to that stuff and just have internet throughout the building, right? There's a couple reasons why that doesn't work. The primary one being, yesterday we talked about gain on our antennas and how our antennas are designed. The antennas on the roof there are designed to be pointing out away from the antenna, out away from the, out in kind of horizontally. And they're actually shooting very, very little signal directly down. So if you have antennas set up on the roof to provide coverage to the homes and businesses around the building, there actually is going to be very little signal making its way down into the building. So that's the top thing. You're not going to want to try to connect customers directly to those access points. Next thing is, if you were to just put access points facing down from the top of the roof into the ceiling, at that point we just run into line of sight problems. That even with the strongest antenna you can get aiming directly down, it's only going to make it a floor or two, and even then it won't work very well because it's trying to penetrate the roofing material and get through a bunch of other stuff into the building, and it's just not going to work very well for those customers. I'll let people get settled and then we'll carry on.
If, for example, I already have an antenna that's not compatible with that use, because like you said, that doesn't go down really. Can I use another building to just bounce off of it and maybe hit the balconies of the apartment?
Yeah, that's a good question. So quickly to catch up for people that just came in, we're talking about MDUs, stands for multiple dwelling complexes. Essentially looking at things like apartment buildings, townhomes, vacation homes, condos, that kind of thing. How can you get service, get it to the building as maybe an intermediary, and then also provide service into the tenants in the building? And the question, first thing we talked about is why using just the wireless gear that you're putting on the roof anyway and letting people connect to that from inside. The unfortunate reality is that the wireless properties just don't work that way. Customers won't be able to connect their laptop from the first floor to your wireless access point on the top floor, regardless of what you do with the antenna. It just won't work very well. Question here is, can you, two parts, can you kind of bounce your signal off of a building next door and have people put wireless access points on their balconies? That probably would work. I don't know that I would rely on the reflection, but you certainly could, for example, hang an access point over the edge of the building, aiming down, and have people put receivers on their balconies looking up and bring them into their units that way. That would work.
Do you end up running into like an interference situation then? All of the CPEs hanging out the windows or whatever?
No worse or better than you would. So the question is, if you were to do that, would you run into an interference problem because all the CPEs are so close together and pointing in the same direction? And it's not really any worse of a problem than you get with homes. You have the bonus being that you can turn the power on those CPEs way down because everything's so close. So you can kind of account for the density by turning the power way down. So, good question. So so moving in from the idea that unfortunately just putting wireless equipment on the roof doesn't quite fix the problem here. That doesn't let us do what we want to do. Moving into one option is to continue with wireless. If these units do have something externally facing, then try to get a wireless access point set up that you can use like from the balconies. That's one way to do it. Some building structures don't really work that way, and it'd be hard to do, but that could be one tool in your arsenal to get this done. Some other things that you could do, if the building has any existing wiring, you can try to use it. So, for example, if you're really lucky, the building already has Cat5 cables run from some kind of centralized communications room to each unit. If that's the case, your job is 90% done. You can bring, if you have your wireless installation on the roof, you bring one cable down from there into their telecom room. At that point, you might install a large router running Althea software so that each client has their own interface. Or you may be able to just use a switch. You can plug in each of these Cat5 cables going into each of the tenants, and then they just plug in directly in their unit, and they're going to get great service because it's all Ethernet all the way through. That's the easiest way to go. Yeah.
But if you wanted to just run Ethernet cables in an apartment complex, but what's the cost for like a new?
Okay. Question. I'm going to answer hers, and then I'll get to yours. The question here is if it's not pre-run and you wanted to run your own Ethernet cables, how much does it cost? The cost can vary a lot, like with a lot of things, depending on how old the building is, what type of building it is, and how you run the wires. If you can run the wires externally on the building, you can do that relatively easily and inexpensively by running them either from the roof down the structure of the building outside and then drilling in, kind of like you would with a single-family home. That can be done fairly inexpensively, still takes a lot of time, but if you're doing the work yourself and running these cables, then it can be done pretty cheaply. If you need to keep all the cable in the building for aesthetic reasons or whatever, that can be a lot more difficult. You've got to find ways to get from floor to floor, run through the risers, get dispersed from the central kind of riser area out into the units. So that can be very difficult, and even more difficult if it's an old building that doesn't have things like drop ceilings and a good riser room. So it can get prohibitively difficult. I think I had a question over here, and then we'll get yours.
I just figured you're probably going to explain this, but I just wanted to ask about the rule of thumb when it comes to assessing how much labor would hooking up a certain building be.
Yeah, okay, so similar to the last question. It's really hard to put a number on it just because buildings vary so much in style and architecture and age and other things. It can vary anywhere from, obviously if it is pre-wired, it can be 20 minutes to hook up an individual unit once you've done a little bit of work up front, where if you have to wire it all individually, you can be spending, a week there with 2 technicians wiring the whole building. Or even more. So it does vary a lot. It's hard to put an exact number on it, but.
So what's an easy building to do? What's a building easy to hook up like, and what's a building that's hard to hook up like?
Yeah. So an easy building. Again, the easiest building is if the cable's already there, obviously. Next easiest is somewhat newish construction. Where they may have drop ceilings in the hallways, and you may be able to, and they may have a good riser room in the middle, the riser room being the room where all the cabling runs up and down in the building. Usually there's fire protection, so they limit the areas where there's open access running from floor to floor. for fire concerns, but a newer building will have an area where there are conduits available that run from floor to floor that you can pull cables through. So if it is a building that has those features where you can run the cabling up and down fairly easily, run it out through the hallways in some kind of drop ceiling, and then go into the units, that's probably the next easiest if you're going to run cable yourself. And you might still spend anywhere from 1 to maybe 4 hours per unit per technician to get it wired that way. And if it's really, really a difficult one, a really old building where you can't do anything externally for aesthetic concerns, I don't even know if I want to guess there. It could be, could be days per unit. It really, really depends on the building. It's hard to guess.
So Graham, what are your thoughts on using Ethernet over power? And it probably wouldn't be a solution for MDUs that have sectioned off their own meters. Mm-hmm. But for older buildings where they share the same power throughout the whole building, would you recommend that as a way to avoid having to wire the whole building?
Yeah. So the question is, what about Ethernet over power? What are some of the concerns there? And would that be worth it? So let me actually kind of combine that with a couple of other more creative options. So kind of in ranking your options, top level option is building already has Ethernet. And then below that, there are a number of other options here that you can compare against each other. So let me run through each of them and then we'll talk about them in detail. If the building isn't already wired for Ethernet, but is already wired with, say, coax for cable TV, or with Cat3 for phone lines, you can build networks on those wires with some specialized equipment. There's some concerns about that specifically that I'll get to in just a second. Another option is Ethernet over power, which does actually work fairly well. We'll talk about that a little bit more in depth in just a second. But the one problem that you mentioned is that it can be really difficult to install if you have to cross a power meter to get to the customer, and that really limits the buildings that it'll work in. So we'll hit that a little more in depth in just a second. And then I think the last option would be doing a full wireless install in the building. So even though you may not be able to just cover the whole building by putting access points on the roof, you could cover the whole building by putting several access points on each floor, maybe throughout the hallways, or maybe even in a few of the units, or up in the like a crawl space in between the floors. So let me hit each one of those individually. Okay, so Ethernet over power. Has anybody used Ethernet over power before? You have several. Okay, so the way it works is you have your outlet, and you plug in a little adapter in one of them, right? And then somewhere else on the power circuit, you have another outlet, and you plug in another adapter over here, and you have Ethernet coming out here and Ethernet going in here. And these from here to here ends up being essentially an Ethernet cable. So it does work quite well. The problem is if there is a meter right here, the signal will not go over the meter, right? So in an apartment complex, in most relatively new apartment complexes, each tenant has their own power meter, so that they each get their own power bill. And if your equipment is up on the roof, the only way for you to get to a plug that's on that customer's meter is to get into their unit. And if you're in their unit, then you're already in their unit, and it doesn't help you at all. So like you said, if it's an older style building or a different style of building where everyone is sharing a single power circuit from the power company, then you can, question?
I was wondering if the meter is often in their unit, I mean, isn't that far enough for you to be behind the meter? To have your other Ethernet over power behind the meter before it goes to the meter and have your Wi-Fi router access point or whatever there?
There are no plugs north of the meter.
Yeah.
So their panel is in the unit, but you can't get north of the panel because by definition, there are no plugs in their apartment that they don't pay for.
Yeah, actually, so the question is there any way to kind of get on one side of on their side of the meter? So let me kind of draw up how physically I've seen it work. Usually at the base of the building, somewhere outside, there's a big meter bank, kind of like that photo I showed in the last slides. And everybody has their own power meter. Sorry, that's kind of hard to see. But it's all in one central place where the electrical company can come by and meter read them all. And then there is bundles of wires going up to each unit. Each unit has a panel. This is your electrical panel that's in a closet somewhere. When a breaker trips, this is where you come in and flip it back on. This is where all your breakers are. This is usually in the unit. This is usually in your physical unit. But there's not any plugs between here and here. There's nowhere to jack it. There's nowhere to connect it. So this is usually in the unit. This is usually not. And if you can get to here, then you're already in the unit, and you can just give them service that way. Does that make sense? Yeah.
Does the type of electrical wire make a difference with the power over?
Yeah, it can. The question is, does the type of electrical wire make a difference? And there are some really old installations that are like the knob and tube service, and it won't work very well over that, but that's really pretty rare to see that. Anything in the last, several decades is going to be fine.
Even aluminum wire?
I think it would be fine. It might cause the ham radio operators in the area some grief, and they'll yell at you, but it'll work. This can also be useful. It's a helpful tool to have in your bag in some situations. A large older home, or trying to get from one end of a unit to another end of a unit. It's nice to know that these Ethernet over power systems are available, and that they work. And so this is nice to know about. But it is hard to fit into MDUs in this situation.
What's like the throughput or anything through that? Like, is it trash compared
Yeah.
to cable? Or?
Good question. The question is, what's the throughput on kind of a modern Ethernet over power solution? And I believe that modern ones claim support of gigabit service across them. I think that there are things that can cause it to be less than that, like if the connections are corroded or not maintained very well or really old or something. But even then, I think it's typically possible in a relatively well-maintained situation to get dozens to hundreds of megabits per second across.
Non-grounded wire? Like, I've got old plugs in my house.
Oh, good question. So, question is, does it require the grounding plug? And I don't think it uses it at all. I think it just modulates on the other wires. Yeah, like two-prong. Yeah.
Does it have to be an unbroken wire, or you could have joints, like if they were to?
Question, does it have to be an unbroken wire, or can it be joined in some places? It does not have to be an unbroken wire. So if you plug in any outlet in the house, you can basically think of it as it will extend to the meter. The only possible exception is in some electrical installations, there are two power circuits running through the house. There's two phases, and I think it does have to be on the same phase. So you usually have two phases coming to the house. Your 220 outlets have both phases hitting them. Your other outlets have one or the other, and I think it does have to be on the same phase. So sometimes half the outlets will work with half the outlets, but not the other half.
Also, it doesn't go through power strips.
Right. Yeah. Yep. Good point. It doesn't go through. Well, it doesn't go through surge protectors. If it's just a dumb power strip that's doesn't have any surge suppression, it goes through, but it will not travel through any kind of surge suppression or UPS device.
So, so when hooking up a building, is there anything really worth considering, like checking out? Okay, what pitfalls can you face and how to avoid it? Yes, that's my question.
Yeah. Well. Yeah, so I think this is probably one of the biggest ones, is how to actually get service from your rooftop installation to the units. In my opinion, that's the biggest thing. If you can overcome that, then you can get service in the building. So I think that's the biggest thing. We'll talk about this power, and then there's a couple other options here that can be good tools for that I think will get you there.
So how about stuff like you think everything's good, but it isn't really? Is there any kind of that stuff going on when looking at buildings when you're nearly finished with the cabling and then something comes up, what types of things could that be?
Well, so there could be problems with the cabling itself. So it's a good idea to test the cabling in your first, when you're surveying it, and make sure that at least some of the cables test good. That's one thing that could come up. Beyond that, there may be things like contract negotiations. You get partway finished, and then the building owner decides they don't like what you did, and that's a problem. But that just involves making sure you're very clear with them ahead of time. Are those the kinds of things you're asking about, or am I missing your question?
Yes, I think
Okay. Let me get through Cindy's next few, and maybe that'll spark some other questions. Any other questions about Ethernet over power? Useful, but definitely limited.
Is there any length, like just physical length?
Question, physical length. Is there a physical length limit? And I actually don't know the answer. I think depending on what one you buy, it'll probably say what it offers.
With my experience, I've hit some limitations, and I got around that by having multiple units and that act as a relay.
Okay.
And
Okay, yeah.
the
There you
signal.
I was wondering if it affects speed. So how can you really get, like, say, 1 gigabit and it will be comparable to actual wire? Or is there any, like, it will affect the latency or speed or things like that?
Yeah, so the question is, would it affect the speed? Can you actually get a full gigabit through it?
Like, if you would consider doing that in an office, for example, that you really need fast speed internet without loss.
Right. So if you're doing it in more like an office environment where you really need that speed, is this a good option? I think the concern there is probably around the quality of the wiring. So I would say it's definitely possible to get this full throughput, and it is feasible and worth testing. But you would want to test it ahead of time to make sure that there's no problems in the wiring that you aren't able to see.
Is there a maximum number of units that can be serviced with this?
Yeah, so good question. Question, is there a maximum number of units that can be serviced with this? One thing I haven't touched on yet is that these are usually point to multi-point, meaning that if I plug in a device and, if I plug in my upstream connection to the internet in one outlet in my home, I can then plug in another unit in any other outlet in the home. They will all talk together, and I can use all of those as individual connections to that same point. So as far as the limit, I think they usually publish, depending on the manufacturer of it, they'll usually publish how many. I think I've usually seen anywhere from like 6 to 12 that they say they support. Oh, go ahead.
Do you have any recommended vendors?
Not really. I think the ones I've used most recently were TP-Link, but there's a lot of different ones. I don't know that one that I don't have one off the top of my head that I recommend.
Just wondering if quality drops off when people are heavily using their power, doing both laundry.
Yeah, interesting question. So could quality drop off if people are like running the leaf blower and the washing machine at the same time or something? It probably shouldn't, although it could maybe potentially introduce extra noise into the environment. So maybe potentially, but it probably shouldn't.
So the way to think about these is that you have a sine wave of power going into your house, and they add little bits of data into that sine wave by like adjusting their individual power draw. So like when you turn on your fridge, you'll you know how lights sometimes dim with the disruption in that sine wave, and power over Ethernet just uses really small versions of that to talk to each other. So you could use a lot of power and it wouldn't be a problem. But if you literally had like a big compressor or some other huge power usage and you're just sitting there going on, off, on, off, on, off, that could be a problem. So that's a lot less of a scenario. That's a lot less common of a scenario.
Yeah. Yeah, I think that's fair. Yeah. Anything else?
So I think I have like 3 questions, but they're sort of related.
Okay.
So okay. So is there any other devices that might disrupt apart from the compressor or anything like that might disrupt the service of Ethernet over power than power meters?
You don't practically have to worry about this.
Yeah, in practice, it's rare to have to worry about that. I guess the only other one would be, like we mentioned earlier, things like UPSs and surge suppressors that you can't try to go through a UPS or a surge suppressor. But in practice, it's rare to run into a device that will disrupt the noise to it.
And do some meters let the traffic through?
I don't know of any that do.
Okay. Okay. Can Ethernet over power be eavesdropped?
Yes.
Okay.
Not if it's encrypted.
It's not a problem for Althea, but in general, yeah.
Okay. Is Ethernet over power strictly point to point?
No. Point to multi-point. Anything on that same meter can be a part of that network. Yep. So let's jump from there to some of the other options that have different trade-offs that might make more sense in your scenario. So there's two other main ones. Well, I guess there's three other main ones. One is if you have coax cables running through the building, which a lot of the times are there because the cable companies came in and put them in, or encouraged the building owner to put them in so that they could sell cable TV. If you do have coax cables, then you have a couple of options for using those to create networks. One of them is called MoCA, M-O-C-A. And another one is G.fast. Both of these you can buy devices that will convert Ethernet to MoCA and vice versa, and for G.fast. MoCA is more specific to coax. The MoCA 2.0, which is the latest version, claims support of gigabit. Oops. And seems to work pretty well as long as the coax cables are in reasonably good condition. Sometimes you might have to recrimp the coax ends because the ends have been corroded or something, but as long as the coax cables are in pretty good condition, you can use them to get something approaching a gigabit throughput across the coax cables. MoCA is also point to multipoint. So you can, at the base of your building, hook up a coax splitter, put one MoCA device on one side of it, and hook up each of the units with their own MoCA device in the room. MoCA devices also have a cable TV pass-through. What that means is that you can hook up your MoCA device, bring their cable TV or satellite TV in one end, your Ethernet in the other end, and have one coax cable going to their unit. At their unit, you take the cable TV pass-through to their television, the Ethernet out to you, or out to their router, and they can have both of those things running across the coax cable at once. Some things to be aware of if you are trying to use MoCA for coax for MoCA. MoCA uses higher frequency ranges to transmit data than are typically used for satellite or internet TV. What that means is that if you are using a splitter or a coupler on the coax cable, you have to make sure that splitter is capable of passing through the frequencies that you're trying to use. So if you just buy the cheapest splitter or coupler you can get from Home Depot, it probably won't work very well. If you specifically look for one that has expanded frequency ranges, it will work fine. This is a great option if the building is already wired with coax. It makes it almost as easy as if the building was almost already wired with Cat5. There's just a few gotchas that I think we've gone through.
Hey, Graham, so with the cable, is it possible to also bypass or to connect multiple houses on a street then if they're on the same cable?
Good question. And it's actually one of the next things I was going to point out. So the question is, can you do this same thing for houses on a street? If they already have coax wired up, can you use that to distribute your own network? The answer in both of these cases is you could, as long as you have the permission of whoever owns the cable. So inside of an MDU, typically the property owner owns the coax cable. And I think that there are actually some regulations around that Comcast was not, or cable companies were not able to maintain ownership of the cable if it's physically in the building. But if the cable is physically in the streets, it's almost certainly still owned by the cable company, and they won't just let you use it. But it is a good point that even inside of a building, you should at least make a cursory check if you're going to use the coax cables. You should at least check with the property manager to make sure that they own, or at least are willing to certify to you that they own the coax cables, because Comcast will not like it if you use their cables. Good question.
What's the
throughput advantages, disadvantages?
Throughput advantages and disadvantages compared to Ethernet. So again, I think they do claim full gigabit throughput, and as long as, again, the couplers support expanded frequency ranges and the cable isn't too badly corroded, you can get something approaching that full gigabit. So.
Is there different types of cable that are better or better for
Are there different types of coax cables that are better or worse throughput? I haven't really seen different types of coax cables cause much of a difference, but maybe really, I don't know, maybe. If they're shielded differently or something. Good questions. Any other questions about coax and MoCA? Cool, I'm going to move on to the next one, which is G.fast, which is very similar. G.fast is an evolution of DSL. G.fast allows you to basically build a DSL network inside of a building that you just own and run. So you can get a G.fast switch that will support something like 8 to 16 units. Those cost hundreds to a few $1,000s. You put that in the telecom room and connect each of the tenants' phone lines into the switch, and then each tenant gets a DSL modem. G.fast, I know DSL gives a lot of us nightmares because it can be so slow at a citywide network, but with these short distances inside of a building, and again, as long as the cables aren't in terrible condition, G.fast does again claim hundreds of megabits to gigabit capability, and on Cat 3.
Okay.
Yeah. I haven't played with G.fast myself as much as the others, so I can't personally verify the claims, but I have heard really good things about it in these exact situations of running basically a DSL network inside of a housing complex.
You talk a little bit about the costs associated with that. It's pretty kind of
Yeah.
expensive.
Yeah, so the question is about the costs. G.fast, the costs end up, so the individual modems are actually really cheap. The part that goes in the customer's home, looking at $50 to $100, which is fairly cheap. The bigger expense is the G.fast switch, which I've seen anywhere from I think $800 to $1,500, which so if you're looking at a 50 unit complex and you're going to be able to fill up all of the every port on that switch really quickly, then that probably starts to make sense. You're still looking at $150 to $200 per unit, which isn't bad compared to a full wireless installation. But if you're only going to be able to hook up 3 to 5 customers, then it starts getting kind of expensive. Any questions about that?
So is there anything about the quality of the phone lines that makes a difference and whether or not this is feasible?
Question about quality of the phone lines and whether or not that makes this feasible. It certainly could. I think it's designed to work in pretty bad environments, and so you'll at least get something through in a bad environment, but it would certainly be worth testing ahead of time, especially if you're concerned about the quality of the cables or if they're really old. Anything else? Cool. Oh.
G.fast.
G.fast, yeah. Yep. So the last thing I was going to talk about is just having wireless throughout the building, which is, I think, when you start talking to a lot of building owners, this is what they would really like to see. It seems like, from the outside, the easiest way to do it and certainly the most convenient for them. The problem is you still end up needing to run wires throughout the whole building because you still need wireless access points basically like every 50 feet. Or maybe even more. You end up needing, at a minimum, you might be able to get away with 1 access point for every 2 units if they're small units, maybe every 2 to 3 units, but most likely you're still going to need a wireless access point for somewhere between every 1 and 3 units, which means you still need a cable run somewhere near every 1 to 3 units. And then we're kind of back to where we started with how do we run those cables. So if you are going to approach the wireless only, wireless throughout the complex, some things you can do. Ubiquiti does make some really good access points that are a lot of times used in corporate networks and hospitals and stuff. They're designed to be installed like in drop ceilings right at the roof level of each floor. You can try to run those through the halls. Sometimes it works well to just, if it is a drop ceiling, run your Cat 5s up above the drop ceiling. These devices are power over Ethernet. You can just install them in the drop ceiling and try to serve everything from the hallways. That can be an easier way to go. You just run the risk of potentially not having very good service out at the edge of the building if you only have access points in the hallways. Oops. Yeah.
Is there like some form of mesh where you could like relay the connection just wirelessly between all the floors?
Yeah, good question. So the question is, can you use a mesh network to relay the connection rather than having to run a wire everywhere? And yeah, you can. So so the concerns with a mesh, the concern with traditional mesh Wi-Fi is that you half your bandwidth at every meshed hop, right?
Single radio mesh, right?
A single radio mesh, because you're using. So if you have all of these wireless access points, and they are each single radio, they each have a single radio. A packet comes in here and goes back out on the same frequency, so it uses the time twice there, the same airtime, and then it does the same thing at each one of these. And so it ends up using, for each hop, it uses the same amount of airtime each time. So it's effectively reducing the available airtime at every hop. So that does make it hard to build a very large traditional Wi-Fi mesh without really killing the bandwidth at the very edges of the mesh. There are some ways around this, like using multiple radios and having your mesh connections go on different channels so that they're not all sharing the same medium. Certainly possible. And ends up being kind of just a miniaturized version of what we're doing here with meshes with multiple radios. Yeah, you could certainly attempt to develop it that way, and it may very well work. I don't know that it would necessarily be easier than running cables, but it could be in some buildings.
Do you know if just like Wi-Fi 802.11s would do enough for that, or is that more for? Because I'm not really sure, because there's sort of like the multi-hop mesh versus just like running Ethernet to all of them and then having them all look as like they're a single access point.
So if you want to do something like that, so 802.11s is a protocol for talking to each other. It's not going to solve your radio problems.
Yeah.
If you really want to do something like that, you're going to want 3 radios per device, and that's going to increase your costs pretty significantly. And it starts to look pretty attractive to have wires, because wires don't have interference. Wires aren't interfered with by somebody who thinks a IP camera is a good idea. Yeah. So yes, the built-in mesh is something you can definitely do, but by the time you've done it to the point where everybody's happy, you probably should have used one of the other solutions.
Yeah, you could if the physical problems we're talking about aren't a problem in a building for some reason, maybe thin walls or something, you could actually use Althea routers would mesh automatically if you set them up that way. You could have it so that each apartment also is earning money forwarding packets for their neighbors, but going through the walls tends to be sketchy, and it might work in some places, it might not work in other places. So
yeah, we have the meshing from router to router as sort of a last hop solution. So like maybe somebody in an apartment wants to serve their neighbor easily, but it's if you're going into a building and trying to hook up a bunch of people, you can do better than that.
Yeah. Deborah sent some signals through the wall to the flower shop lady.
No, yeah. Well, we have an actual Ethernet cable.
Oh, you have an Ethernet cable?
Yeah,
okay,
we actually
okay.
use outdoor Ethernet cable, and it's
Got
running
it,
along
got
the
it. Okay,
outside
never
of the
mind.
building.
Case in point.
Yeah. So, although I think that that might potentially be an interesting use case if you had like a lot of times people have an apartment below, and you could just probably better run an Ethernet cable between the 2 routers instead of. Yeah, I mean, almost always, if it is possible to run a cable, that's going to be a better connection.
Yeah. Just to repeat what Deborah just said, almost always, if it's possible to run an Ethernet cable, it'll be a better connection. But if it's not possible, then consider wireless. So those are when I approach an MDU or a town complex, those are usually the things that I'm looking for and ways to do it. Any other questions about the whole thing overall or each of these options?
Can you maybe or at least clarify the definition of airtime that you could use?
Yeah, sure. So the question is, can I clarify the definition of airtime that I just used? So, and this applies to some of the wireless stuff we talked about yesterday, as well as what we're talking about here. So if you remember yesterday, we talked about these devices, these wireless devices can only ever be sending or receiving at once. They're only ever either transmitting or listening. And really anything on the channel is ever only transmitting or listening at once. It can never be doing both. And only one device on the network, of all the devices that can hear each other, only one of them is ever talking at any given time. So essentially what that means is that each device, in order to talk, has to fit into time. Every device has to wait for a turn to talk. And so there's only so much time that can be used and only so much that can be said during that time. So if you are removing time from the available pool of time to be used to send traffic, then you're reducing the efficiency of the access plane across the board. Like so. Does that answer your question? Cool. Anything else? All right.